Since fuzzing involves a lot of input-output operations, including writing a lot of temporary files on the disk, the lifespan of many hard disks or SSDs might be reduced. To fix this problem, we can use a RAM disk in a way that all the writing operations are done in RAM. If you want to know more about this topic, in the fuzzing in depth section of the AFL documentation, you will see a specific chapter about this topic. Otherwise, just continue with the video and I will show you how to create a RAM disk. So we switch back to our terminal and the first things to do is to create the RAM disk folder. So we run sudo make dir to create our folder. Since we created our folder with the sudo command, we have to change the owner. And we do it with the change owner command. And we set our user as the owner of the folder. Finally, we can mount it with the mount command. In the mount command, we use the tflag to specify the type of the file system to be mounted. In that case, it's a tmpfs, which is a temporary file system that is stored in RAM. This is really fast, but its content is lost when the system is rebooted. Then, with the O flag, we set the maximum size of the temporary file system. In that case, we set the file system. We say that the file system will use up to 2 GB of RAM, or swap space if needed, for storage. And if this size limit is exceeded, the system will prevent future data from being written in our directory, in our mount. Tmpfs is just the source of the mount, and it doesn't refer to an actual block device or file. It simply means that you are using a tmpfs type of file system which is created dynamically in RAM. Okay, so the next step is to move our input, all our examples into the RAM disk. So we create another folder inside the RAM disk and we call it in for input. And we copy all the test examples already provided with tcpdump. We copy all the tests inside the in folder. And finally, we can mount our RAM disk inside our podman container. So we run podman run and we specify our RAM disk to mount our RAM disk into the root folder /RAM disk, and we also specify an environment variable used by AFL inside the container. This variable tells to AFL++ to use RAM disk as its a temporary directory for storing files that are used during the fuzzing. The number 3 is just a shortcut to reference my Docker image. Since I have just one image in this machine and it starts with 3, I can just use 3. Okay, so now I am inside the container and I can move inside the RAM disk folder, and I will see that I will find the in folder, and inside the in folder I have all the tests that we copied from tcpdump. Okay, there is also another way to use podman with the RAM disk. In that case, we can create the RAM disk directly from the podman command. So we run again podman. We specify with the mount flag to mount a new type of file system, a temporary file system, and we specify the destination, that is again RAM disk. In that way, we don't have to mount a pre-created RAM disk, and this is created dynamically when we spawn the container. Also in this case, we have to specify with the AFL tempdir variable where AFL should put all the temporary files. I will use again 3 because it's the shortcut, it's the name of my image. Now, as you can see, if I go inside the RAM disk, I have no files because this RAM disk is different from the previous one. This is a new RAM disk that was created dynamically during the spawn of my container. In general, I prefer the first approach because I can easily access the mounted RAM disk also outside of the container. For example, if I want to monitor the output folder of the fuzzer. And before concluding, I would like to highlight that using a RAM disk provides faster input-out performance, but carries the risk of data loss during, for example, power outages or system crashes, as all the content is stored in RAM. and it's volatile and will be erased when the power is interrupted. So remember to always backup your output directory periodically or after a fuzzing section.